Before going into the details on working of a clutch, let's see how it is assembled in motorcycles. The power from the engine is converted to rotary motion by the crankshaft as shown. This power is then transferred to clutch housing. The clutch assembly transfers power to the input shaft of the gearbox. The power is then transferred to the output shaft and eventually to the rear wheel of the motorcycle. The clutch assembly itself is a combination of several parts. It consists of a pressure plate held in place by using several springs and screws. This plate presses against the clutch pack. The clutch pack consists of several steel and friction plates placed in alternate positions. The clutch basket and the inner hub are assembled with their axes aligned to the input shaft of the gearbox. Now, let's understand how a clutch works. The clutch basket freewheels with respect to the gearbox. The engine power will spin the clutch basket, but it will not transfer any power to the gearbox. However, the inner hub is connected to the input shaft of the gearbox. If we spin this inner hub, then it will also spin the gearbox input shaft. Let's take a hypothetical connector with teeth on its internal and external portion that can interlock with both the clutch basket and the inner hub. If we insert this hypothetical connector between the clutch basket and the inner hub, then we can spin both of these at once and the engine power reaches the gearbox. And if we remove this hypothetical connector, the clutch basket and inner hub will be independent again and the engine power is disconnected. But there is a problem in using this connector. When the connector is removed, the inner hub spins due to inertia of the motorcycle rear wheel, and the outer basket spins due to engine power. This is why these two components start spinning at different speeds. In order to interlock with both of these non-synchronized spinning components, the hypothetical connector will have to spin at two different speeds at the same time, which is impossible. For example, if it matches the inner hub speed, then interlocking this connector with the outer basket will be either impossible or too difficult. To eliminate this problem, the clutch pack is used in place of this hypothetical connector. Unlike our hypothetical connector, the clutch pack is a combination of separate circular plates. Let's take any two adjacent plates from the clutch pack. One of them is a friction plate and the other is a steel plate. The friction plate has teeth on the outer circumference, which always interlocks with the clutch basket and can slide sideways along this clutch basket, but doesn't affect the inner hub. The steel plate has teeth in its inner portion, which always interlocks with the grooves in the inner hub and can slide sideways along this hub. This plate spins with the inner hub, but doesn't affect the outer basket. As these plates can slide sideways, we can press them together, gradually increasing friction so that both of them start acting like a single unit, like our hypothetical connector. With this arrangement, if we spin the outer basket, the inner hub will also spin. This will eventually transfer power from the engine to the gearbox. Even if the plates are spinning at different RPM at first, the gradual increase in friction between them will eventually synchronize them. If we release the pressure, the two plates become independent. This will disconnect the inner hub with the clutch basket, and the engine power is disconnected. Several other plates are added to increase strength and surface area. Now let's understand how pressure on these plates are changed while riding a motorcycle. We use the pressure plate for this purpose. It has ducted attachments where a set of springs can fit in. A set of retainer bolts are screwed to the inner hub. This causes the spring to compress and apply force on the clutch pack, resulting in sufficient friction between the plates. We can release the pressure on the clutch pack by pushing the pressure plate outwards. We can control this pressure by pulling or releasing the clutch lever. As the clutch lever is pulled or released, a cable or hydraulic system rotates an actuator arm as shown in the animation. This arm presses against the push rod towards the clutch. This rod goes through a duct inside the input shaft and pushes the pressure plate, releasing the pressure on the clutch pack. When the clutch lever is released, The springs again apply pressure to the clutch pack, as shown in the animation.